This tutorial is for educational use only. It is not authorized nor approved for any other use.
It's time to complete the Masterchef Smart Contract.
Net2Dev.
In this tutorial, we are finally building the stake, unstake, and auto compound functions. Very obvious. Stake, we are staking tokens on xPool. Unstake, we are removing or withdrawing tokens from xPool. Auto compound, we are not unstaking, which means that I am not going to be removing those tokens from the pool. Instead, I want to grab the amount of tokens that I earn. I want to grab those tokens and I want to restake those tokens, okay? I don't want to remove them. That is auto compound. But here's the scenario with auto compound. We need to make sure that the token that I am going to pay the staker is the same token that I am allowing to stake. For example, I am staking my tokens in pool 0, which in this case is the N to the R pool. I will be paying N to the R tokens. That means that I can grab those tokens and I can restake those tokens, okay? If we don't have that scenario, that it's not the same, then we cannot do auto compound because I will not be able to allow a user to stake tokens that are not in that pool, right? So we are going to perform the auto compound by allowing users to stake their reward tokens as long as they're the same ones staked on the pool. We'll test a couple of scenarios. Deploying the smart contract finalized, we'll stake 2 types of tokens, then we'll issue the unstake, we'll issue the auto compound, and you will see how everything works, okay? It's very important to understand how many tokens are we going to be paying to the staker based on the amount of tokens that they stake and the duration of that staking period, which means that what? Last reward block and the current block. Those are my 2 values that will determine how many tokens do I have to pay to the staker. But it's very complex. Like, this math is complex because we're not talking about a single user. We're talking about a pool of many users. And I just cannot pay the same amount of tokens to someone that staked 1,000 tokens than someone that staked 1,000,000 tokens. So I have to be able to come up with the formula that will allow me to distribute equally the amount of tokens that I'm going to be paying to each staker. And that, ladies and gentlemen, is the reward token per share value. That basically determines you have X amount of tokens. I will be paying you the reward of X amount of value per token. I will be able to pay everyone equally. Calculate and get a final token reward per share amount, and that will be the amount that we will be multiplying against the user amount, and we'll pay accordingly, okay? With that, the last function that we are going to be coding is going to be the emergency withdrawal, which is part of this last video. The emergency withdrawal, if you are not familiar with DeFi exploits, this is one case where I hope that you don't need to use this function, because what happens is, for some reason there was an exploit and you need to remove the tokens without even caring about how much you earn. You are going to lose those earnings. That function will be coded to do just that. Another scenario, let's say there was an issue on the code. There was a bug on the code that prohibits users or stakers to remove their tokens from the pool. You want to have that function just in case you need to do an emergency withdrawal, okay? Again, it's there just if we need to. Ideally, we don't want to use that, okay? But we'll code that. It is all part of the Masterchef Smart Contract. Once we are done with this video, we'll do one last video. And you know me, we are going to be doing the front end. We're definitely going to be doing a front end so we can finally connect the smart contract, and we'll have a web front end that users can interact and stake the tokens and see the rewards, query those rewards, and make sure that they can see how many tokens have they earned during a staking period. They can do the auto compound, they can do unstake, they can do all that, okay? And we'll add a couple of tokens onto the pool, and we should be able to see different sections on the staking page that will allow the users to stake per pool. So we'll do all that. We'll do the front end, we'll code the front end, we'll connect the smart contract, and we'll call this full tutorial a success, okay? Alrighty, enough with the talking. Let's go ahead and let's finish the Masterchef Smart Contract. Okay, in the last video when we configured the updatePool function, one thing that I did, and to be honest, it's not going to be the best approach, and I admit it, it's not going to be the best approach to send the end-to-the-R tokens once they're minted back into the Masterchef contract. And the reason why is it's because when we start minting the rewards, the math formula that will determine how many tokens do I have staked on the pool, that the math formula is going to be affected. And the reason why it's going to be affected is because those tokens, the ones that I'm minting, if I deposit those tokens inside the Masterchef contract, from a math perspective, those tokens appear to be staked. And that is not good because it's definitely going to lower even more the reward because there's, quote, more tokens staked. Okay, but that's not the case. So what we are going to do here is we are going to be minting, but instead of specifying that I want to send the tokens to this address, which is the Masterchef contract, I am going to be sending those to the token smart contract. Okay, what do I have to specify here? It's going to be the N to the R. So I'm going to say N to the R. What this is doing, it's telling the smart contract, send it back to the token smart contract, which means I have to add an interface that will allow me to move the tokens from the token smart contract. So I minted the tokens, but the tokens were deposited onto the token smart contract. So we have to have an interface that allows us to take that out. Okay, so what I'm going to do, I'm going to open my reward token, my contract, and I'm going to place the function that is going to allow us to remove those tokens and transfer those tokens to the Masterchef. Okay, let's do it. Now I'm going to go to the token smart contract. In the token smart contract, you can see here, this is the end to the rewards smart contract. I am going to specify another function that we will use in the Masterchef contract to remove the tokens. Okay, so I'm going to write real quick here, function, and we are going to say safe into the R transfer. Okay, so we are going to be declaring this function with safe into the R transfer. Now I need to provide the address that I'm going to be sending the tokens to. So from the token smart contract, I will be withdrawing those tokens where? So I have to specify to, which I will be providing. And then I will be providing, obviously, the amount. So UINT256 amount is underscore amount. And now we are going to be calling this external only. So nothing internally needs to access this. Okay. And finally, I can start the function, which is going to be very quick. So what I'm going to do first, I want to make sure that only the wallet that has this role can do this. Okay. Which in this case, we have to add the Masterchef contract as a manager of the token smart contract, okay? Which is fine. So now I want to make sure that if I execute this function from the Masterchef smart contract, I want to make sure that if I do have tokens already minted here, I withdraw those tokens first. If it's enough to satisfy the payment to the staker and they are already minted and just awaiting here to be withdrawn, I want to make sure that I do that first before reminting or minting new ones. Okay, so what I'm going to do, I am going to declare another variable. It's going to be called UINT256, and I'm going to say into the balance. Okay, so we're just going to declare this, and now what I have to do, it's declare balance of, which is one of the interfaces on the ERC20 token smart contract. It's balance of, allows me to know the amount of tokens in a particular address. From there, I'm just going to specify myself address this, which means it's the token smart contract. I want to know if there's tokens staked or stored in this particular smart contract. So with this amount, now I can determine if I already have the tokens or if I need to mint tokens. If underscore amount, which is the amount that I'm going to be requesting to transfer, is more than the N to the R balance, right? Then you know what? Send me first the balance that you have, then send me the rest, okay? So what I'm going to do, I'm going to just say transfer, right? And we are saying to, and what are we transferring? The N to the R balance, which is whatever it's left in this particular contract. Beautiful. Now, what I have to do here, else we are going to say this. We are going to say transfer. If it doesn't, just then give me the amount. That should be good. I think we have to clear this. Beautiful, done. Okay, so this looks good. And I think we're good here. So very simple, if amount that I'm requesting, it's higher than the balance, you can transfer that balance because that satisfies the payment requirement or the transfer requirement. Else, just transfer whatever the amount is, okay? Which is fine, okay? And this will be called when we update the pool, right? So when we do an update to the pool, the smart contract is going to determine, the Masterchef is going to say, well, I need X amount of tokens because I need to pay this amount of stakers and this is the amount. Well, let me go ahead and request that from the token smart contract. The token smart contract is just going to send those tokens to the Masterchef smart. But we initially have to mint those tokens, and that's where the function that I was talking to you about, the mint here, comes into place. So I will be minting those tokens, but they will remain in the token smart contract. If then we got into the point that you're going to see now, I need to pay the staker, the tokens are already minted. So that's the whole purpose of it. Awesome. So we're done here. Now, here's the next function that we have to work with. Now we are doing the following function. The function that we are going to be writing now, it's going to be the set allocation point. What is that going to do? It allows us to raise the allocation point for a particular pool so that we can provide more staking rewards to X pool. We want to do a bonus. We want to give more incentive to a particular pool for a period of time, then we can do it this way. So this allows us to modify the allocation point. And you remember at the beginning of this tutorial, we mentioned that the allocation point, it's basically the percentage of tokens that I will be distributing to the stakers based on the pool that they're located at. Okay, so if I provide an allocation point of more tokens for pool 1 than for pool 0, then that's the distribution. We are specifying that with basis points. For that said, I am going to write this function that is going to allow me to update that. Okay, so let me scroll this up. There we go. We're going to call this set. Okay, and this will be passed with what? I have to first of all say the PID because I need to know which pool am I going to be modifying the allocation point. Now I want to provide the new allocation point value, which means that I have to pass that. So I'm going to say alloc point. I'm going to say bool, and I have to specify with update, okay? And let me explain to you what that is. I'm going to say this is public, and obviously it can only be called by the owner of the smart contract, obviously. Okay, with update, we are going to add a condition. If I pass true when I make this call, I will be performing an update to all the pools to update the reward, to update the reward per block, to gather the amount of tokens staked, everything. I want to make sure that the pool has been updated, which means that I will be calling the update pool and I will be executing this entire math formula and the calculations. If I need to mint tokens, I will mint tokens. I will do everything I need to do before changing the allocation point. And you might say, well, why you want to do that? And the sole reason why you want to do that is you want to make sure that when you apply the allocation point, it starts a brand new, clean, updated value or amount across all your pools for all your values. Last reward block, the reward per share, all those values, I will be updating those values before I change the allocation point because we're going to have a slight difference, right? So with that said, and you know that I mentioned the allocation point, the moment I update the allocation point on one of the pools, pool 0 definitely is going to go down, pool 1 is going to go a little bit down. Remember, I have a finite amount of tokens that I'm minting or I'm generating, and I have to make sure that I work with those tokens across all my pools, okay? Now, if I say yes, so once we mention yes, if I say with update, if I said yes or true, then I want to do this, and check this out. So what I want to do is I want to update my pools. But here's the thing. One thing that I forgot, I have to be able to update all my pools, not just one pool. I have to make sure that I update all of them because the allocation point affects all the pools. Even though that I'm going to be updating it for a single pool, I have to make sure that I rebalance the allocation point across my pools because the end to the upper block is fixed. It's not like it's going to raise. It's going to stay the same. If we're mining 10 tokens per block, we are mining 10 tokens per block, regardless of how many pools do we have, okay? So with that said, I am going to be doing another function on top of that will call the update pool, but it's going to do it in a loop. It's going to call the update pools across all the pools that I have available, okay? And this function is going to be called mass update pools, okay? So let's write it down, okay? So let's type function, and we're going to say mass update pools, right? And we are going to call this public. And this doesn't matter if a user calls this function, because again, this is something that will be auto called when we do a stake unstake function. So doesn't matter. Anyone wants to update the amount of tokens that they have earned, when they click update in the web front end, this will be called and then their tokens will be updated. Else, we have a function that will automatically give you that value. On the pending reward, it's going to give you that value, and you're going to see that. I am going to now say UINT256. This is very straightforward. I'm going to say length, right? And we're going to specify this is the length of the array, which in this case, I just need to know how many pools do we have, right? Pool info.length, we know this is the dynamic array that we're storing all the data. All my pools are stored right here. And now I'm going to say UINT256, and we are going to specify PID. I am going to say PID going to be less than length, right? And I just want to raise the PID value, right? Cool, beautiful, awesome. And what do I need to call? UpdatePool. What do I need to pass? The PID. That's it. Beautiful. Okay, so if I have 3 pools, then this value will be 3. PID starts with 0. We know that in Solidity, when we declare the integer, UINT256, it's 0 by default. So you don't have to like add equals to 0. No, it's already 0. So it starts with 0. And then I'm just going to start raising it. So it starts 0, 1, 2, 3, and such. Okay, so we're done here. Now I can effectively say the following. If I pass update true, I'm going to say mass update pools. Right, we're going to call that function that I just called, and this should take care of the updating, right? Beautiful. One thing, the more pools you have, the more is going to incur in gas fees, because you are calling update pool per pool, which means that I am calling this entire function, and I am minting, I am doing all kinds of things in the smart contract, right? In the blockchain. If I have 10 pools, that means that this function is going to be called 10 times, which means that I'm going to be minting twice each call. 10 times is 20 minting calls, basically. And I am going to do some math formulas, which is not that bad. However, it's definitely going to hit on your gas fees. So you want to make sure that you be careful when you do this, okay? Alrighty, let's continue. Now, what I'm going to do, I am going to say the following. Let's continue. Let's see UINT256. Now I want to update the allocation point. This is the whole purpose of this function, is to update the allocation point. First of all, I need to determine what was the previous allocation point, right? So I have to declare that. Previous allocation point. Where do we obtain the previous allocation point? So let's say if I decided to update pool ID 1, which is the second pool, I want to know what the previous allocation is for pool 1. If we go up, I'm going to show you where that value is stored, right? We have this stored under the pool struct. So if this is a good way to find it, like this will give it to me, right? This is all we need, but ideally you want to see it right here. And you can see the pool info struct. And how do we map it? It's basically the way that I just copy it right here, right? So all we need is this. You can see that I'm very lazy. Okay, cool, awesome. Okay, so I have allocation point previous. Okay, so this is how we obtain that value. Now I am going to say that the allocation point, right? Because we have stored the previous value. Now I can effectively update this with the new value, right? So I'm going to say this, I'm just going to pass allocation point. And now if the previous allocation, it's not equal to the new allocation, then I want to make sure that I update also the total allocation, which means that every time that we change the allocation point, the total allocation, what's the total allocation? It is the sum of all my pool allocations. So if I have 1,000, pool 0, 2,000, pool 1, 3,000, pool 2, 3, 2, 5, 1, 6. So 6,000 will be my total allocation. That means that if I've updated the allocation for a single pool, I have to update my total allocation. Okay, so make sure that you do that, or else the math is going to be incorrect. You don't want that, especially in DeFi. Okay, so now I have to confirm that. I have to say if previous allocation, it's not equal to the allocation value that I'm passing, which is definitely going to be the case, then it's going to update my total allocation. I want to update that. How do we determine the total allocation? We are going to be subtracting what I had before and add the new allocation. Check this out. Total allocation is the total amount that I had stored in the smart contract. This is the total amount of pool allocations. We're going to be subtracting the old pool allocation, which is previous, okay? And then I am going to be adding what? The new allocation. This is straightforward math, okay? So if I am going to just write it here so you can see it. It's very simple. So I'm going to say, total allocation, let's say it was 6,000, right? Now we are going to subtract that by the previous allocation. Had 1,000 and we are updating it now with 2,000. There's something as a reference. So previously it had 1,000, right? We're just adding it 2,000. That's it. That's literally the math. The result, it's the new total allocation. Once we are done with that, I want to update the pool. And boom. What we do now, we update the staking pool. If you don't remember what function was this, let's just recap real quick. Update staking pool, what it's doing? It's going to update my allocation point, and it's going to give that bonus to pool 0, because we want to make sure that pool 0, it's increased as well. And what we are doing right now is we are raising a little bit pool 0. So we are adding an extra overhead to pool 0 in the allocation point. That's it with set. We are done. Let me just fix the syntax a little bit here. And now we're going for the good stuff. Now this is a fun formula. This is going to be the pending reward. This function is strictly to show the user how much tokens are they earning while staking. And this will allow us to display that in the front end. This is very important, and this basically has the entire math formula that determines how many tokens is the user earning. Okay, so this is very important. So let's start this fun here. Function, and we're going to call this pending reward, and let's start. So the first thing I'm going to be passing is UINT256. We're going to say pool ID. Obviously, I need to specify pool ID. And now I want to know the address of that user, right? Because that's what the user is going to be calling once they connect the wallet onto the app. That's what the function is going to be pulling the data from, okay? For that particular user. We're going to call this external view, and this function will return the integer value. Basically, the UINT256 is going to be in way, but we will do the math calculations or the formatting in the front end. Okay. And now what I have to do, first of all, I have to obtain the mapping for the pool and the mapping for the user. And we already have done this on previous videos. I don't need to go again with that. We have done the pool mapping. We haven't done the user mapping, but we'll do it right now. So I have to find the pool mapping. I'm just going to copy, here it goes. I'm just going to copy this because I am using this. This gets me access into the particular pool that I'm calling and I'm requesting the information. Now I have to do the same thing for the user. In this case, I am going to be calling the user info mapping, right? And it's also part of the storage. And we're just going to declare this value to be user. We will use user to interact with the struct, with the user struct. And now I am going to specify the following. Remember at the beginning when we started writing this smart contract, the user info is a nested mapping, which means that I'm going to go up to show you. Here it goes. The mapping is looking for UINT first. What is the UINT value or the integer? It's going to be the pool ID. After it obtains that, then it asks for the user wallet. And then that's how I can obtain the information for a particular user. Okay, so if you can see it here, I will be able to obtain the pending reward and the amount. Okay, so don't worry. And let's go back down here. So now the first thing that I'm going to be passing is what? I am going to be passing the pool ID. Remember the mapping? Now, remember it's a nested. Now after the pool ID, I'm going to be asking for the wallet, which means that I have to pass another one. And I'm going to say user. That's the user wallet address that I'm passing on the function, okay? Now, let's obtain the token reward per share. This, again, this is the amount of tokens that I'm going to be paying for each staked token. So I have to stake one token, the pending reward, it's the amount that I'm going to receive in exchange for that staked token, okay? So I have to obtain that value because I'm going to be doing the calculations, okay? UINT256, and I'm going to say reward token per share, okay? Now, how do I obtain that? Where is reward token per share stored? It is stored in the pool storage, okay? So if we go back up, I am going to making sure that this is very clear to you. So you can see here, reward token per share, it's inside the pool struct, okay? So it's part of it. So all I have to do in order for me to gain access to that value is type pool, and I'm going to just call reward token per share. Okay, that's how I obtain the value for that particular pool that I'm calling. So I got the variable with the value stored. Now I can use that. Now, the next thing I have to determine is the amount of tokens that I have staked, not just for this particular user, but for the smart contract, which means that how many tokens are staked in the pool. that this user is requesting the information from. Because again, that's how we determine how much tokens it's that particular user going to receive. Because there's more users staking tokens, which means that his reward is, or her reward is not going to be the same as someone that has staked 1 million tokens, right? So we have to make sure that we have that discrepancy. That's how we obtain. We have to first determine how much tokens are staked on the pool, and then from there we'll do the math to determine how much is the user obtaining. So liquidity pool supply, how do I obtain the amount of tokens that I have staked in the Masterchef Smart Contract? Very simple. I am going to be calling the token smart contract that I'm going to be staking in the pool. So how do we do that? We are going to be calling what? The pool, again, calling the pool, but now I have to invoke the address of the contract that I am allowing to stake. And then we'll say balance of, right? And from what wallet or what address? It's the smart contract, the Masterchef. So I have to say address. What address? This, the smart contract, okay? So that's how I know how much tokens are in the smart contract state, okay? Beautiful. So we have the liquidity pool supply. Now I can effectively say the following. Check this out. If, okay, block number, what am I doing? I am making sure that the block number, it's higher than last reward block was stored, because that tells me that it has passed some time. And also that there's stake tokens in this pool, or else I'm not going to obtain any value, okay? So with that said, I have to say the following. If block number it's higher than pool last reward block, again, this is the last time we interact with this particular pool, either someone staked, unstaked, we will constantly update this value. But also I want to make sure that not only that, block number is higher than the last reward block. Also, I have to say this. I am also going to require that the liquidity pool supply is what? Is not 0, which tells me what? There's stake tokens. If it's 0, that means that no one has stake tokens on the pool. Okay? Awesome. So we are looking very good so far. Now, here's the fun part. We have to do the math. Okay? So the first thing that I'm going to be asking, okay, I'm going to be looking for is going to be the multiplier value. Okay? So I need to know how much time did that user stake the tokens, okay? Which means that I have to obtain the last reward block and the block number, and also the bonus multiplier, and determine how many blocks, and we multiply that value, okay? And that tells me how many blocks have been processed during the time that that user staked the tokens, and that tells me a very, 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 very close estimate time of how long did that happen. For the multiplier, we have a function that we already wrote, and you can see it up here. This was literally the first function that we coded. It's basically obtaining from the last block to the previous block. We are going to be subtracting those two values, like the current block number and the last reward block number. Subtract that. The result is then multiplied by the bonus multiplier, which is that bonus that we use to increase or double or triple the amount of tokens that the user is going to receive. Okay? So with that said, all I have to do is call that function, get multiplier, and I'm going to say first in the formula, last reward block and block number. Those are my two values that I have to make sure that I subtract, okay? Now I have the multiplier. So let's say, for example, 4 blocks, right? We subtracted those two values, and then there's a multiplier of 2. That means that this multiplier value is 8. 4 blocks, multiplier is 2. 4 plus 2, 8. Okay, so we have that multiplier value, just for thought. Now the token reward, okay? UINT 256, token reward. This is the amount of tokens that I have to distribute to all the pool. To the entire pool, I have to distribute this amount per token, okay? Check this out. First of all, I'm going to say the following. I'm going to say multiplier. If you want to know this function or the math formula, the first video. I covered this in the first video. You are going to obtain the entire breakdown, okay? Multiplier. So first of all, we have to say multiplier. We are multiplying that against what? The N2VR per block. That is the amount of tokens that I'm mining every block process. Every time a block gets processed, I will be mining a token. What also do I have to multiply? The allocation point. Very important. how many tokens from there am I going to distribute onto this pool? So we're going to say pool, and we're just going to call allocation point. We're interacting with the storage for that pool. So if I pass pool 0, we are grabbing the values out of pool 0, okay? Got it? And finally, whatever is the total of all this multiplication, once we multiply all that together, we are going to be dividing this by the total allocation, okay? This is how we determine how much we are going to be giving to that particular pool. Total allocation. Beautiful. Awesome. So now we have the amount of tokens that I have to deposit or I have to issue to this particular staking pool as the reward, okay? Now I need to determine how much is the reward per share. How many tokens am I going to be giving per each staker? If I have 1 token stake, this is the reward per share. This is how many tokens am I going to give you as a payout, okay? So let's say reward per share, token per share. We are just basically passing the value that we obtained previously. Now I have to update that value because this is going to determine how many tokens it's a user going to obtain, right? We're going to say reward token per share. Once again, I have to consider what I already had before in the token per share. I'm just going to be updating that with the new per share. If it went down, fine, it's just going to go down. If it went up, it's going to go up. It's all based on the formula. The formula is going to determine that because we're going to be dividing by the amount of tokens that we obtain and all that, and this will effectively lower or up the emission of tokens as payout, okay? So I'm going to say reward token per share, and we are going to be adding the token reward, right? Because that's the total amount of tokens. And now multiplied by Sabo 1e12, this allowed me to shrink that total amount that we obtained. It's going to be a weight value, but it's not going to be a precise number. That real number is going to be, and you're going to see it, it's going to be that particular amount of tokens that we are providing to the staker. This particular formula is going to show as a very, very low number. But remember, this is happening every block. That doesn't mean that this is the entire payout for a long period. This is actually per block, but then from there, I do the multiplication based on how long did the user stake the tokens for, okay? So I'm going to say that, and then I'm going to be dividing this by what? By the liquidity pool supply, right? Why do I do that? Why do I have to do that? I'm not the only one that I'm staking. There's more people staking in the pool, which means that I have to consider the entire amount of tokens. This will tell me how much can I give to each staker. It's up to you. If you stake more than another user, you will definitely receive more, okay? Now that I obtained this entire value here, now we can effectively tell the user how much have they earned. Now we are just going to tell them, let's return that amount to them. How do we determine that? We are now going to be calling the user struct, and I need to know how much tokens is that user staking in the pool. After I obtain the amount of tokens that the user has staked, I am going to multiply that value by what? By the reward token per share. This is the amount of tokens that I will be giving to the amount of tokens that the user has staked. Simple. We'll say divide. We are, again, formatting the value. We are using Sabo for that, right? So we are dividing that 1 factor of 12. And finally, check this out. We have to subtract whatever the value it's here against the reward, the pending reward that I was about to give the user. So let's say the user already had a pending reward, right? What we are doing is we want to make sure that this doesn't count with this particular reward, meaning the user already got those tokens. We want to make sure that they don't think that they still haven't gotten those tokens. The user earned 100 tokens. The user claimed those 100 tokens, okay? That it's going to be stored in the smart contract as the pending reward, whatever we pay to the staker. That amount, ladies and gentlemen, is still there, but we have to make sure that that is not counted as a new reward because we already paid that. So what we're going to do, we're going to make sure that that value is subtracted from the new pending reward. You got it? Awesome. And we're going to say user, and we are going to be passing pending reward, which is the other value that I have for that user struct. Pending reward right here. Okay? Call that And we are just going to paste that in, and ba 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 ba. This is literally the most difficult. The stake and unstake, they're very similar. Okay, you are going to see that. Okay, we are doing now stake and unstake. So now the function that I need to add, it's a function that allows me to call the token smart contract and issue the safe transfer or the safe into the art transfer. Remember at the beginning, we coded that in the token smart contract. That function, I have to add it here so then I can make the call to the token smart contract and do the transfer. Remember, the token smart contract, it's going to be holding the tokens that we are generating once we click the updatePool function, okay? So when we update pool, we are sending the mint request to the token smart contract, and we are also holding the tokens in the token smart contract. We have to communicate via that interface and request those tokens to be transferred and deposit or delivered onto the staker's wallet, okay? So with that said, what I'm gonna do, I'm going to be calling a function. We're gonna call this function, and this function name is gonna be safe, just like the other function in the token smart contract, the same. Transfer, okay? And now we are going to say address, right? To, so in this case, it will be the staker amount, right? So UINT256 amount. And this will be internal, which means that this is only going to be used when the user either stakes or unstakes, okay? Let's do it. Internal. Got it? Beautiful. The only thing that I need to do now is enter the R, save transfer from. Save into the R transfer, okay? And I just passed the values to an amount. That's it. That's all we have to do. Now, finally, stake, okay? So let's call the function stake. Okay? And as a matter of fact, I'm gonna leave this function right at the end. We're gonna do it right here. Function stake, woohoo! All right, stake. First thing that we are going to be asking, the pool ID, obviously. Next thing that I'm going to be asking, the amount. How much are you going to deposit? Okay. And this will be public. Okay. Very important now. I have to make sure that the pool exists. And I have to make sure that the pool ID is valid. Remember in video number 1, we did the modifier. Remember when we did the modifier? I'm going to show you right here. Validate pool. So guess what? I'm going to be using that. Let me grab that. And we're going to go under stake and we're going to say validate pool. And so now I am going to head to the modifier and we will determine if the pool ID is real or not. Okay. Beautiful. So now I can effectively start the function. Okay. So let's write the function. The first thing that I have to do is map. I have to build that variable that allows me to talk to the pool. And we already saw this, and also the variable that allows me to talk to the user struct, okay? So what we can do is what I know what to do, copy and paste, okay? So we are going to be copying pool info storage and user info storage. Here, we're not passing the user address because this is strictly called by the staker, which means that all I have to do, message sender. At that point, I'm just gonna record whatever the address is of the caller to this function, okay? Beautiful, so now we can work with the pool and we can work with the user. Let's make it happen. Now, first things first, I gotta make sure that the pool values have been updated. The reward per block, that the allocation, everything is up to date, which means that every time a user calls the stake function, I'm gonna take advantage of that and make sure that the pool has updated values, okay? So what I'm gonna do, I'm gonna say update pool. That's the function that we coded in the previous video. And what I'm going to be passing, the PID. That's it, okay? So with that, I am effectively updating that particular pool before then I interact and stake or unstake whatever I need to do, okay? Now what I'm gonna do, if user amount, that means that if the user that is talking to this function, the wallet that is calling this function, if the amount that is already stored, because remember, we are actually calling the storage in the smart contract, which means that this information is already stored in the smart contract. So if the user amount, okay, check this out, it's more than 0, the user already has token staked on the smart contract. Now what I have to do, I have to say, well, if that's the case, I need to determine if we have pending balance to be paid to the user. Yes. So when the user stakes, if we have already some reward pending to be claimed by the user, I am going to send that reward to the user. I'm going to take advantage and just claim anything that we have pending to pay to that staker. Okay, so I have to first determine the value of that. Okay, so let's do that. UINT256, and we're going to call this pending, right? And we are going to say user amount. Now we are going to do the math. Multiplied by what? The pool reward token per share. This is, again, one stake token. This is how much I'm going to pay you. Okay, this is actually stored in the pool. So we are going to be invoking the pool storage. And now I have to find the reward token per share. You can see that it auto-populated there. Okay, awesome. So I have the value. Now what I'm going to do, I am going to be dividing that, right, by the Savo value. Remember, we are formatting, like I explained to you before, we're formatting it using the Savo unit. So I am going to be dividing that so then we can truncate the value of the amount of tokens that I'm going to be paying, okay? And then we are finally going to be subtracting that from any reward that we already recorded to be paid by the Masterchef contract to the staker. In this case, if I already paid something, I paid 100 tokens, as the reward, I have to make sure that that last reward that has been paid, or the pending reward has been paid, so then I can update that with the new value, okay? Check this out. It's literally what we did right here when we did the pending, right? We are effectively dropping that or subtracting that from the call, okay? Awesome. So we're good here. This is literally the formula. Now, let me scroll up here. Now, once I do the math and I do have an amount of tokens that I need to pay to the staker, I have to make sure that's the case, which means that I have to do an if condition here. I'm going to say pending. I'm going to say if pending is higher than 0, that means that I owe rewards. I owe staking rewards. I have to pay that to the staker. Now, what am I going to do? You remember the function that we coded? We are going to be calling that function. Hey, token smart contract, send me this amount. What amount? The pending amount. So we are first telling the smart contract, initiate the transfer of tokens from the pool of tokens that you already have. We already preminted those tokens and those are stored in that contract. Send me from that pool to this address. So I'm telling the address of the staker, and I'm going to be passing what? Pending. So whatever I'm owing to the user, to the staker, I'm going to be paying at that moment. Okay? Beautiful. So we are done with the first check. Now we have to do a second check. Okay? So the second check is to store the new tokens. So remember, we are staking tokens, which means that I'm going to be depositing, we are going to be storing those tokens onto the pool. So we are depositing those tokens onto the pool. So with that said, I have to say the following. I have to make sure that the amount that the user is passing, right, this amount, I have to make sure that this is also higher than 0, okay? So which means that if it is higher than 0, then I want you to execute the transfer onto the pool. How do we do that? We are going to be calling the pool storage. Now I have to interact with the liquidity pool token. This is the token that I'm allowing to stake in this particular pool. I'm calling the token smart contract in this case. And now I am going to execute the safe transfer from, right? This is the normal safe transfer, safe ERC20. Now I am going to be passing the arguments. Like I'm going to be passing the arguments onto that call, which in this case is going to be what? It's going to be from the sender, message sender, right? Now I am going to say from message sender to where? Address this, the Masterchef Smart Contract. I'm going to be transferring to stake those tokens onto the Masterchef Smart Contract. And what is the last value? The amount. That's the amount the user is requesting to stake, okay? Beautiful. Once I'm done with that, I need to update the amount in the user struct, in the user storage, to whatever the user has staked, okay? So in this case, I'm just going to say user amount, right? Whatever the user already has staked. Remember, the user might still have stake tokens. We don't want to withdraw those tokens. The user wants to add more tokens. What we ended up doing before is just paying the user anything pending from the reward, from the earnings. We didn't withdraw those stake tokens. They still remain on the pool. So we have to consider those tokens. First, we have to add the new token amount, and then that will be the updated user amount value. Okay? Simple. And we are just going to say add amount. We have to make sure that the pending reward, it's updated as well, which means that, remember, every time that we have a block process, we have generated a reward, which means that this function is going to be processed in a block, which means that I already have to pay the staker something. Okay? So what I'm going to do, I am going to be updating the pending reward, right? This is where we determine how much is the user earned, how much has the user earned for staking their tokens. So we have to update this particular value. Okay? We are going to be updating it with user amount, right? We are going to be multiplying. We are going to be determining how much is the user going to earn per every block process. Okay, so in this case, the same pool reward per token shares. Like every token that I have, I'm going to pay you this amount. It's straightforward. I hope that you know this already. And we are going to be formatting this in Sabo, so it's 1E12 once again. And that's it. Now we are effectively updating the pending reward, which is literally just one block. The moment the user stake, this is literally updated. Okay. One last thing that I haven't done, and we have to make sure that we keep track for auditing purposes, it's to track each time a user stakes or unstake, we are going to be emitting an event. And that event will be logged in the blockchain, and then we can have a script to query that information and show that in the front end if we want to. Okay. So for that, I'm going to show you real quick. Okay. So we are going to be inserting, okay, the 3 events that I'm going to be declaring: deposit, withdraw, and emergency withdrawal. And you're going to see emergency withdrawal, which is what I mentioned earlier in this video. In case there's a major issue in the DeFi Masterchef contract that prohibits the user from unstaking any bug, anything, or even an exploit, God forbid, right? We have an exploit in the Masterchef Smart Contract. We still want to make sure that the user can unstake those tokens right away. Okay, so we have an emergency withdrawal. We'll do it right now. Okay. So for that, I'm going to paste this in. So this is a straightforward event. So what I'm doing is declaring an event for deposit. The first event is just going to store the user wallet. It's going to store the pool ID, and it's going to store the amount that the user deposit or staked in the Masterchef contract. The same goes for withdraw. It's the same, the amount that the user decided to unstake from this Masterchef contract. And now the emergency withdraw is literally the same thing. Like from which pool did the user execute that emergency withdrawal? Okay. So that's there. Now I can effectively use those events and call those events here on each function. So now with that said, I can effectively call the emit. So I'm going to be calling that event. Emit, what's the name of the event? Deposit. Okay, we just declare that, and you can see right away that it auto-populated that, but PID, it's not like that, and amount is not like that, but let's change that, okay? And then user is not going to be user. It's going to be message sender. That's the wallet address of the staker. We'll control S, and that looks good so far. Good so far. Now on stake is literally the same thing because I still have to pay any pending reward. The only difference is going to be it's the transfer from. We are transferring from the smart contract to the wallet instead of the opposite. The user transfers to the Masterchef contract. Okay, so we are going to be calling that once again. We're just going to copy the whole thing. It's literally the same. We're just changing a couple of things. Okay, so we are going to say now unstake. Okay, and in the unstake function, all of this is the same. We haven't changed nothing. I still have to pay the pending reward and all that. Here's where we are going to be doing the unstake itself, the removal of those tokens. So we are now, instead of adding, we have to make sure that we subtract that. So what I'm going to do first, I'm going to make sure that I subtract that from the Masterchef contract. And instead of add, we are just removing the tokens, subtracting the tokens. And now here, we are flipping those two values, right? But then we are doing transfer, okay? So we are doing safe transfer. Now it's going to be from the Masterchef contract to the wallet of the staker. So in this case, this is 2, and the other parameter is going to be amount. That's it, and done. Boom. And one last thing that I have to do is to make sure the pending reward, again, I have to update that, because if the user decided to unstake not all of the tokens, which is going to be, it's possible that the user didn't want to unstake all of them, we still have to pay that first emission rate, right? So the first block, we have to pay that. And now we are just going to switch this to withdraw. And that's it. Let me just delete this. Beautiful. We have done unstake. The only thing that changes is this parameter here. We're subtracting the amount from whatever the amount was staked, and we are transferring those tokens to the user. That's it. Awesome. One other function, and we are effectively done. Okay, so there's 2 functions, the emergency withdraw, and we have the auto compound function. Let's do it. So auto compound, in the beginning of the video, I mentioned that auto compound is when the user doesn't want to unstake the tokens, but the user wants to restake the earnings. It only applies to pool 0, or the pool that both the token that I'm allowing to stake and the token that I'm paying the stakers is the same. Else, we're not going to be able to do this, okay? Auto compound. Let me just raise a little bit here, right? And we are going to be passing public. I don't need to pass any parameters, because this is something that is already in the smart contract. It's whatever the user has earned, just need to call the auto compound, and we are going to be associating that and finding out how much the user has earned, and we will stake those tokens back. Okay, we'll grab that, we'll make it and store it back. Okay, obviously the first 2 things that I have to interact with, the pool and the user, so I'm just going to go ahead and copy this. Okay, so I'm going to copy that, and I'm going to say, because you can see now it's asking me for a PID, but remember, the only pool that both the stake token and the reward token are the same as pool 0, which means that that's the only pool that I'm going to be allowing to do this, okay? Now here's the cool thing. You remember when we either unstake or staked, if there was a pending reward, which is the value that we are going to be working with now, I would transfer that to the staker. No, in this case, I am not. What I'm going to be doing is adding that to the user amount. That's the only difference that we're doing here, which means that what I have to do is I have to copy this. Literally, all I'm doing is that, okay? I'm gonna say here, I'm gonna paste it here, and now check this out. I am not going to transfer that to the user. Instead, what I'm going to be doing is redepositing those tokens back. Okay, so I'm gonna say user amount. What I need to do, I am going to grab whatever the user already has staked. We're not gonna change that. We are just going to add what was pending as payment. So the user didn't want to unstake those rewards. The user wants to restake those rewards. This is where we do it, okay? Beautiful. But now I have to make sure that I update the pending reward, because we already paid the last reward. In this case, whatever was pending, we pay that, okay? So make sure that you do that, or else you're double paying the staker, okay? So what I'm going to do, I am going to grab this liner right here, which is literally the same. And that is it, ladies and gentlemen. Okay, cool. Auto compound, it's done. Control S, beautiful, beautiful. Okay, that's it. Now the 2 functions that I have to work with now, it's going to be the emergency withdraw, which what it's going to do is going to do the safe transfer. It's not going to care about the rewards or anything. It's going to just allow the user to unstake without any payment, okay? Okay, so let's go ahead and type it here, function emergency withdraw, okay? And we are going to, oops, and this has to be camel case, okay? And we are going to say here, just the PID. All I need to pass to the smart contract is going to be the pool ID, right? We still have to interact with the pool and user storage, right? So we still have to, obviously got to make this public, and we're just going to interact with those 2, but it has to be this one that allows the user to specify which pool. Okay, so now I'm passing that value. Now I can interact with both the pool and the user, okay? Now, after I've done that, now I can say the following. I'm just going to say pool, and I think I got it here. Okay, this one right here, transfer. That's all I'm going to be doing, okay? So I'm gonna say pool token transfer, and I am going to find out the amount that the user has staked. How do I find that? We already have it. It's on the storage. It's going to be user.amount. That's the amount of tokens that the user has staked in the vault, in the pool. Okay, so that's the amount. And now the Masterchef Smart Contract is just going to give that amount to the user. It doesn't care about the rewards at that point. And I have to now emit that event. Let's emit the emergency withdrawal, right? And what I have to do, I am going to pass message sender. I'm going to be passing the pool ID, and I'm finally passing the user.amount, which is the amount staked in the smart contract. One last thing, and we are done with the emergency withdrawal. It's going to be to reset the values. Remember, we haven't resetted the values. The Masterchef Smart Contract still thinks that the user still has those tokens staked. So we have to remove that from the storage. Also, user pending reward, anything is 0 because we already paid that, okay? And boom, that is done. And the last function, we have to make sure that if you want to change the developer wallet address, you can do so, obviously if you have the rights to do it, okay? So what I'm going to do, I'm going to say function. It's very straightforward. Change def. And now we are going to be passing address, the new address that I want to change that developer. Remember, this is the address, the wallet address that I'm going to be sending the developer payments or the developer fee payments, okay? So that's it. I'm going to say public. But obviously, I got to make sure that no one can call that function, which means that I am going to do a require. Let's check, right? Let's check if message sender is equal to the developer, okay? Or else you're not authorized to do so, okay? And I am going to grab the old value, which is stored globally. I'm just gonna update that with def. And that's it. We have done the smart contract. Let's go ahead and test it. So what we are going to do now, we are going to do a quick test. We'll make sure that we are able to stake on stake. We'll take a look in the blockchain explorer and we'll call this a success, okay? So let's take a look here. Control S, okay? And now let's deploy this. I got my wallet connected. Let me use another wallet, okay? So let me go ahead and transact, deploying the token smart contract now with the function that we just coded. Okay, now I can deploy the Masterchef contract. So let's select the Masterchef contract. And finally, I can do this. I can say the entity rewards smart contract. It's this one right here. We're going to paste the token smart contract. And now the developer address is this wallet. And the entity upper block, again, we mentioned 10 tokens, okay? Which means that this is in way. Let's convert that to way. Okay, so we type 10. This is the value. And we're just gonna paste that in. Start block. Let's find what the block number is on Sepolia. I'm deploying this in the Sepolia testnet, okay? And the last block is going to be 435087.3. Okay, so let's add that there. And the block multiplier, so the bonus multiplier, we can say it's 2. So we're just going to do a multiplier of 2, and boom, there goes the Masterchef Smart Contract. We are going to be confirming the transaction. Boom, and we got the Masterchef Contract. Awesome, beautiful. Now the next thing that I have to do is to mint, because it's a brand new token smart contract. I have to mint tokens, okay? So with that said, I am going to mint to myself, let's say 200,000 tokens, something like that. Okay, so I'm gonna just convert it right here, right? 200,000, let's copy the value away, go back, I'm gonna say 200,000, and I'm going to specify that you mint to my own address. Okay, I'm gonna mint, waiting for that mint to complete. And now I have to add the Masterchef Smart Contract as a manager of the entity rewards. Remember, unless you have this role, else you're not going to be able to call those functions, okay? So easy. So all we have to do now is going to be, first, you know what? Before we do that, I am going to allow the Masterchef contract, and you are going to see this on the next video, which is the front end. I have to make sure that the Masterchef contract has approval to move the tokens from my wallet, okay? which means that I have to tell the entity rewards, hey, allow the Masterchef contract to move the tokens on my behalf, okay? So I'm going to grab the address of the Masterchef contract. I'm going to tell the spender is the Masterchef contract. I'm just going to put a long number. I'm just going to allow a lot, but ideally you don't want to do that, okay? In the front end, we are going to be specific. We are going to be approving only the amount that the user wants to stake as security, okay? Beautiful, so that's done. Now I am going to add the role to the Masterchef contract. So I'm going to copy the spender address, which is the Masterchef contract, and we are going to grant the role. So let's grant the role, and we're going to paste the account. Now we're going to find the role, manage the role. I'm going to grab that, copy it, and we are going to paste it here, and we are going to grant the role to the Masterchef contract. Beautiful. Okay, with this, the Masterchef contract, it's binded to the token smart contract. Now, the Masterchef contract can do the minting, can do the transfers, can do all that, okay? Beautiful. And I should have 200,000 NTDRs in my wallet, okay? So let's find out. Okay, so I'm going to copy the token smart contract address, and I'm going to add that here. Boom. There we go. We got the 200,000. Awesome. Now I can stake. Okay, awesome. Let's stake. So what I want to do, I am going to head to the Masterchef Smart Contract, and we are, remember, the first pool is when we deploy the smart contract, it's going to be pool 0, which is the N2DR pool. Okay, so I don't need to like add another pool. We'll add another pool now. So what I'm going to do first, I am going to stake here. So let's go ahead and stake. We're using pool 0. And we are going to be staking, let's stake 31,000 tokens, okay? Let me convert that right here. 31, 1, 2, 3, copy and paste, okay? And we are effectively staking. Boom, 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 boom. The first stake function. Awesome, we have staked. Let's take a look and see what we see here. Okay, so we know the start block, pool length. We have one pool, the first pool. Okay, and now if I take a look at pool 0, let's see what we see now. We can effectively see the token smart contract address. We see the allocation point, which is 1,000. That's default when we initialize the smart contract. And we specified that in the beginning of the video. And the smart contract, if you want to take a look and see again, it's right here. The allocation point, this is pool 0. And the total allocation is literally just 1 because it's a single pool. Okay, now with user information, I can see how many tokens has the user staked in the contract and the pending reward. If we are pending to pay the user, we should be able to see it here, which means that I already staked. The Sepolia testnet is like the Ethereum mainnet. It processes the block every 12 seconds, which means that every 12 seconds, I should see this counter. 12 to 15 seconds, I should see that pending reward incrementing, okay? So first of all, I'm gonna provide pool 0, which is the pool that we are working with, right? Pool 0, I think this is gonna be better for you. Pool 0. Now I'm going to be providing the wallet of the user. So in this case, it's gonna be my wallet, okay? And we are going to call, okay? So you can see right here that I effectively have 31,000 NTDR. This is in way. Reward debt, it's 0, okay? Why I don't see this incrementing? Well, this is when we update the pool. We should see this incremented based on the amount of tokens that are staked, okay? So we have to do that formula. We have to do all that calculation that we just did with the update pool. This is where all the magic happens. In update pool, I will be updating all the information regarding the user, okay? So with that said, let's take a look at the pending reward, okay? So what I'm going to check, I'm going to say pool ID 0. I'm going to be also specify my user wallet. And boom, this is the amount of tokens that I've earned so far. If we grab this value, we convert that. Let's see how much that is. 219. That means that it's 10 tokens per block. And since I've been talking here, how many blocks have been processed, I am the only one in the pool. And there's 31,000 tokens, of course, obviously. Yeah, and it's per token. So yes, this is accurate, okay? 219, but as people start staking, the more you stake and the more people are staking, this number obviously is going to lower, right? If I go back, let's take a look at that and recall this should have changed. Beautiful. It has changed. Now it's 25. So it's 259 tokens. Okay. Awesome. Now what I'm going to do, I'm going to stake on behalf of someone else. So I'm going to, first of all, I'm going to transfer tokens to another wallet. So I'm going to transfer tokens to another wallet. So let's go here. And I'm going to grab my tokens and I'm going to send from those tokens to this wallet. Okay. I'm going to be sending, let's send 100,000 tokens. There we go. So we're going to be sending 100,000. I don't know if you can see it because it's like my video is like right in front of it, but you'll see it, don't worry. So I'm going to say next and let's transfer that. Okay, so we're transferring 100,000 to another wallet and I'm going to use that wallet to stake. Beautiful. Now let's go to the other wallet. So the other wallet is going to be this one. No, not this one right here. Okay, so I will have to add the token. So let me go ahead and add the token. Okay, so I'm going to import the token into the R and boom, I got 100,000. Beautiful. Now let me go ahead and stake. Okay, so what I got to do, I got to change. It's already changed. So now I'm going to stake on pool 0. And now what I want to stake, let's stake 75,000, which means that I have to like convert that. 75, 1, 2, 3. Okay, so when I copy it, let's go back. I'm going to paste it here and boom. Oh, allowance. Okay, great. This is good that it happened. Remember, we have to approve the Masterchef contract for moving the tokens. Okay, so let's go ahead and do that real quick. So I'm going to go into the rewards and I'm going to call that function, which is literally what we called. And next, and approve. Okay, now the Masterchef contract should be approved and now we should be able to stake. So wait for that. Boom, has confirmed. Now let's go ahead and stake. There we go. Beautiful. Let's go ahead and stake here. Beautiful. Okay, awesome. Now, another thing that we are going to do, we are going to take a look at the staking info for this particular user. So let me take a look here. And you can already see that the reward that has been updated. Why is that? Why is that? We have staked, which means that the update pool ran and obviously updated that value. Okay, so every time that the update pool, every time that we do a function in the Masterchef contract, is going to update the pool and it's going to update the values, which is great. Now the pending reward, I can effectively take a look at that. Boom, boom. We already see that this wallet has earned staking rewards. So I'm going to go ahead and 42 tokens. Beautiful. Yeah, and it makes sense because it's literally staked just now. Okay. Another thing, let's go ahead and unstake. So what I'm going to do, I am going to be unstaking from the other wallet. So let me go ahead and switch the wallet. Okay, I unstake. Let me go ahead and now wait for the wallet to connect and we should be done. Okay, let me go ahead and unstake. And we deposit on this wallet, it was 31,000. So let me remove 5,000. Okay, so I'm going to say 5,000 here. I'm going to copy. And I am going to head to Remix and I am going to unstake 5,000 from pool 0. And there we go. We are going to unstake. Okay, let's take a look. Let's see now how much. Let's take a look at the transaction. We can see it right here, right? We can see that transaction. So view on Etherscan. Let's see. This is recent as now. Let's wait for that to finish. And we'll take a look and see the distribution. There we go. Awesome. So check this out. From this means it's a brand new token emission. It's a mint function. What happened was the following. I received minted tokens, brand new tokens. I received 200 tokens that were minted by the Masterchef Smart Contract to the token Smart Contract. Okay. This, ladies and gentlemen, right here, it's the amount of tokens that the developer address received. And remember, the developer address is the same address that I'm using to stake. But this execution right here is when we deposit 10% to the developer, okay? Which means that I effectively earn 200, okay? So that is the last reward. And any other pending reward was transfer from the token smart contract, from the Masterchef smart contract to the wallet, okay? So, and finally, obviously, I got my tokens back, my 5,000. So I got a new emission of 200. I got the existing reward that was already pending and stored in the smart contract of 638. And I got my 5,000 tokens back. Beautiful. Okay, so let's cut it here. We are officially done with the Masterchef Smart Contract. It's staking, unstaking. Everything has been configured. On the final video, we are doing the front end and we are going to be adding multiple pools and we'll have fun with multiple pools, okay? That's it. Let's cut it now and we'll see you on the final video.